So, like Matt said, my name is Jason Shiplett. I'm a double VCDX, desktop, and data center virtualization. I'm a principal solution engineer for VMware EUC solutions at SimpliVity. I do all the reference architectures, stuff like that. So, session goals today, we're going to learn something new about VDI and challenges. We're going to understand HCI, so hyperconverged infrastructure versus traditional infrastructure. And we're going to gain some strategies for overcoming VDI challenges that we're going to lay out using HCI. So, central challenge of VDI, and you can't really see it very well in that. So we have these three groups: users, IT, and the business. And they have competing goals. So they're all driving toward the same thing, but they have different drivers to get there. So your users want a reliable, always-on experience. They want, the same as their traditional desktops, but they want the my data and apps everywhere. So they want to be able to access their applications. They want to be able to get to their data from any device, from from a tablet, from an iPhone, from a Mac, from a PC, and they want to be able to do it from anywhere where they have an internet connection. And then when they get to those applications and data, they want it to be responsive. You can't have 15 minutes to log in to get to your desktop. It needs to be usable out of the gate. Now, business, the imperatives that the business has are to enable and retain the users. So this is where we can, as IT administrators, use IT to keep and retain users that are, they're going to be selective on where they work. And if you can give yourself competitive advantage over someone else who may not offer, that ability to, if I want to, pop into a session at 2 o'clock on a Friday morning and get some work done, then that's a thing that you lose. Minimum total cost. So this is one of the more stark differences between the business and the users. The users want a great experience and they don't care how much it costs. The business has to keep the cost down. And then lastly, the business needs a speedy return on investment. So they don't want to invest a ton of money up front and then never realize any of the gains that they expected out of that investment. Now, IT is kind of caught in the middle. So IT has to deliver this environment. They have to deliver, the desktops and the applications to the users, and they have to do it in a way that's highly available. The risk associated with data loss and data unavailability is huge. If I have, depending on the sector that the customer's in, that could be, thousands, hundreds of thousands of dollars per minute of downtime. So other things that we're running into here, so expensive siloed infrastructure. So typically, you're going to have your servers and your server admins that manage those, your storage and your storage admins that manage those. And that's a source of inefficiency. Demand spikes and login storms, so that's, everybody gets in at 9 o'clock and tries to log in at the same time, and that's a ton of I/O on your storage. And then difficulty scaling, so, and we'll get into that a little bit more in a little bit. So where do we go from there? So you overinvest, you buy everything 100% up front. Your users are really happy, but there's no ROI in that. Alternatively, you can underinvest, not buy, top of the line everything. Users won't use the solution. Terrible ROI. So from there, we can compromise, do something, in the middle. Users, they'll use it, but they'll not be real happy about it. And that's a low ROI type solution. So we're going to talk about these 4 challenges, so complexity of IT infrastructure, sizing and scaling, demand spikes and login storms, and resiliency and data protection. So above the hypervisor, the management tools are largely going to be the same no matter what you have below. what we're talking about doing to simplify the infrastructure that support your VDI desktops is taking the servers, the storage switch, the HA shared storage, the SSD array for your Composer replicas, your backup appliance, so you can back all your servers and all your full clone desktops up, your WAN optimization if you want to move data across a WAN, a cloud gateway if you want to back up to a cloud provider, storage caching, and data protection, and move that all into one easy to deploy building block. And lots of different images for it. So that's the idea. We take everything on the left and put it into an easy to deploy, scalable building block. Now, on the sizing and scaling, I like this quote and the part at the bottom the best. So when you're rolling out VDI, you try a small number of users, you think you have it figured out. You do a POC, you get some users on there, everything's great. And then you try and scale up and everything falls apart. And Gabe's absolutely right. If you look at the amount of I/O that is required for your POC of 100 users, and this is kind of a simplistic representation. This is assuming 10 IOs per user. My 100 users, that's 1,000 IOPS. My traditional infrastructure can handle that just fine. Once I start getting up towards 1,000 users or 10,000 users, the I/O balloons. So the infrastructure required to support that, if you're all of a sudden talking all flash, or you're talking tons and tons of spindles to service that I/O. If you can't meet that with the storage that you're putting underneath this, what happens? Our latency gets driven up, and when that happens, user acceptance, it just tanks. You can. One of the things that I like to talk about is login storms, and you get your users. Oh, I thought that was the next slide, but it's not. So you get your users logging in at 9 o'clock, and you can tell in a lot of environments, and I've had to troubleshoot a fair number of them. The calls start coming in, 9:15, 9:30. I still can't log in. It's not working very well, and that's absolutely a function of storage latency, 99% of the time. So the idea that we want to put forth is to start small and scale out. So you start at 2 nodes with your pilot. Every VDI project should start with a pilot. You get your users on there, you get some success under your belt, and you're ready to roll into production. And with SimpliVity, you take your pilot environment, you add additional OmniStack nodes into it, and grow into production. And from there, you've had 6 months, a year of success, and the business is saying, okay, I'm ready to move forward. What do we want to do now? We want to get additional use cases in. We want to expand to remote sites, things like that. And from there, we just scale out the environment, add additional nodes into the federation, and you're off and running. And we want to scale out intelligently. So you think about traditional SANs and how they're architected. So you have storage controllers, and then you have disk behind those controllers. And you scale them up till you get to the point where you either exhaust the I/O that the controllers can do, or you can't add any additional spindles to increase the I/O that you want to do. So you buy another SAN, put it in, and start scaling up again. And that's inherently problematic if you think about it from a perspective of cost. So we'll say I have a SAN and it'll do 10,000 users. I put my 10,000 users on there, it cost me $150,000, $200,000. Now I want to put my 10,001st user on there. Either I'm going to sacrifice performance, or my 10,001st user just cost me $250,000, which is a huge deal. So we want to take that and kind of turn it on its head and do the storage in a linear scale out model. So we want to tightly couple the storage and the compute, scale them out as needed, and do it in building blocks where, you know, the delta between one and the next isn't $250,000. So demand spikes and login storms. So this is the login storm slide. So absolutely a big deal if you're talking about, you know, you may not have a boot storm per se, but you still have a large number typically of users logging in at any given time. Even if you have multiple shifts, you have, you know, 7 a.m., 1 p.m., 7 a.m., and you end up with a huge amount of I/O, and this can also include antivirus storms. If you have to, or if you're mandated to do full scans, this can also be a huge problem. Even if they're staggered, it's a very large amount of I/O. And if you can't, so the idea is if you can't keep good performance during these types of spikes, then, you know, you're going to get calls into the help desk. So the best I/O is one you don't have to do, and this is the idea behind the data virtualization platform. So if we can, we want to eliminate any I/O we don't have to do, and the way that we do that is through inline deduplication. So we're not only deduping the data that goes down to disk, but we're deduping the I/O as well. We have some average efficiency stuff up there. Full clones. So let's talk about link clones and full clones. So link clones are a great idea for a number of reasons, one of which is data storage. So if we talk about the amount of data that's required to store with link clones versus full clones, it's usually on the order of, you know, 30% versus a full clone. And the ability to do that deduplication, we remove that. So if we're talking about doing full clones, and, you know, if you have a state-of-the-art SCCM implementation, we don't want you to have to abandon that. So your full clones are stored just as efficiently as your link clones in that case. The other way that we minimize I/O is through predictive caching. So we have an algorithm that will look at what's being done in I/O and promote the most frequently accessed blocks into cache. And that way, instead of having to go down to disk, it's much, much faster if we're doing it through memory or SSD cache. And that segues into this graph. So this is Login VSI. If you're not familiar, it's a performance testing tool for VDI. What the blue line is an average response time, and the red line up there, the one that goes all the way across, is the point at which performance becomes bad. So we did a test where we had 1,000 link clones, and we ran the test. Typically, a Login VSI test, if you're going to do 1,000 users, is like 2.88 seconds per login, so a little under 3 seconds per login. We did it at 1 second per login to try and simulate a boot storm, and you can see here, it really never flinched. We never got close to the point where users are going to have a bad time. All right, lastly, we want to talk about resiliency and data protection. And this is something where, at least for me, it's kind of exciting because I've been doing a lot of work in this area over the last 4 or 5 weeks. So when it comes to high availability and data protection, VDI has been your VDI users are second-class citizens a lot of the time. You don't think about backing up individual desktops. You know, you might redirect data to a shared folder or something like that, but individual desktops aren't really paid attention to. High availability is not always prioritized for VDI. Users face data loss and downtime. So if my desktops aren't backed up, if I'm not redirecting my data, then my desktops go down, the infrastructure supporting it goes down, I face data unavailability or data loss. And the way that we approach that is pretty unique. So every instance of a virtual machine lives on multiple nodes. So when a write comes in, it's not acknowledged until it's been replicated to a secondary node. So if we have a failure of a node within the cluster, we have no risk of losing the data on those virtual machines. The infrastructure also automatically detects node failures and individual component failures. So if I have a failure on one node that takes the storage down, my VMs on that node don't necessarily go down. The storage on another node takes over, everything resumes as normal. And that has been validated by login VSI. So I mentioned login VSI. I have another login VSI chart here. So the testing that we were doing here was on a 4+0 cluster. So this is 4 nodes in a vSphere cluster with 1,000 desktops running on it. So this is an office worker desktop. It's a 1 vCPU, 2 gigs of RAM, kind of a medium level workload. And we were initially running 250 desktops per box, and then we failed one of them completely. So we failed the storage and failed the compute. And then ran this login VSI test with, it's over 300 desktops per machine. And we get kind of close when we approach 1,000, but we never breach that line where that VSI max line where performance becomes problematic. That's typically seen as the point where you're going to start getting phone calls into your help desk. And we never hit that line, even with over 300 desktops per machine, which we wouldn't recommend doing, but it shows you that we can't do it. So disaster recovery and business continuity. So let's talk about BCDR in the event of a site outage. So our site A goes away. Replication between the sites protects user data and applications. So we have, this is a typical always-on kind of design if you're familiar with the architecture. So we have multiple sites, a load balancer in the middle, and users get directed to either site A or site B. Site A and site B are both built so they can take 100% of the load across both sites. So all I'm failing over there, and you can see I don't know if you can read it, but it says site B primary and site A secondary. So I have my site B desktops up and running, and nothing really happens with them. The site A secondary pool there is a link clone pool that's powered off, just there in case site A goes down, or if you need to do maintenance or whatever and fail over. So those desktops get spun up. My SMB server or file server on site A fails over to site B, so my site A users still have all of their applications and data. And the global site load balancing solution redirects users to site A or to site B when site A goes down, and that does it. So, and like I said, I just got finished doing some validation testing with this, and it was, even though I've been working with SimpliVity gear for a while now, it's always interesting to see how well things go. It was failing over from one node to another, bringing it up, and then doing a SimpliVity move back to get it back on the primary site. It's easy to do in a lab because I've stretched L2 between my lab nodes because they're sitting right next to each other. But in a production environment, you can do stretch L2. You can also leverage solutions like VM 2020 EasyDR to automate the failover process and failback as well. That'll do some of the orchestration of things like, if you need to change an IP address, change DNS, stuff like that. Now let's talk a regional disaster. So this is where a typical active-active configuration for Vue, even in an always-on design, you usually have data centers within a region. So I might have a data center in Dallas, I might have a data center in Austin. I want to keep the latency from my Vue clients and my Vue agents, so between the end user and where the desktop lives, to a minimum. So typically that's going to result in a couple of regional data centers. So let's say both go down. So this could be anything from, if I'm in California, an earthquake, if I'm up in Boston, a nor'easter comes through and knocks out my New Hampshire data center and my Boston data center. We need to be able to recover that data, right? So we can't let something like that take out our entire, take out all of our data, take out all of our infrastructure. So we back up to a tertiary site. This can also be back up to cloud. If you have the budget for it, you could be backing up to a tertiary site where users log in, or it could just be a disaster recovery site. Now let's talk about full clone BCDR. And this is something that I'm quite excited about because it's something that I haven't heard anybody really talk about. So we have the same kind of scenario where we have two data centers. I have a global load balancing solution in the middle that'll direct users to where they're supposed to go. What we're doing now is we're backing those individual desktops up across sites. And then we do a temporary recovery of those full clone desktops on the secondary site. And like I said, this can be anything from, someone found their backhoe and went and cut some fiber, or the data center went down, or it could just be maintenance. We need to take the network core down in site A to do some maintenance, and we need to flip over to site B. So we temporarily recover on site B, and then we fail back to site A once it comes back online. Using a SimpliVity move, we can reinstantiate those desktops into their original pools, so there's no additional management overhead when I fail back. All right, and to summarize, balancing user expectations and business imperatives with IT realities. So we have to size and scale properly. Performance and peak workloads have to be taken care of. We need to keep costs down, we need to keep complexity down, and we need resilience and uptime. And what we bring to that is simplified deployment. You have these x86 building blocks with predictable performance per machine. If I have a workload where 100 users fits on a machine or 200 users fits on a machine, I know if I need to add 1,000 users, I add 5 blocks or I add 10 blocks. Linear scale from the pilot to production. So my pilot, I start small, I scale out into production. Unmatched and independently validated VDI performance. And this is something that Matt was noting earlier. We are the only vendor at this point to have a VDI or login VSI validated solution. So what we did is we had login VSI do a WebEx with some of our engineers, and they ran the tests. We didn't run the tests. And no one else has done that. And then we have built-in resilience and high availability. Any questions?
So what are your GPU capabilities within the building block?
So we can do GPUs. Today we support NVIDIA K1, K2, and M60. So that's a second generation grid. We can do that in our Cisco UCS OmniStack boxes. It's not something that we do in our OEM box, but you can do it in the Cisco boxes.
We also have the, sorry to jump in with Matt Boak, Solutions Architect of SimpliVity. We can also add what we call compute nodes. We're alone in the industry for doing this today. So any standard x86 folks don't care if it's a B-series blade, C-series chassis, R720, DL3, I don't care. Just mount our NFS data store, and any VM running on that data store gets everything that Jason just talked about, right. And it comes to you at the cost of the commodity components. And so you get a big 2U box, 4U box, fill it full of K2 cards, and do your...
Right. On top of that, we're also validating a solution with a vendor called Magma. They do PCI expansion boxes, and you can put additional GPUs into those.
So you'd roll your own building block. You'd build a building block that had the storage. I mean, how would you construct this modular scenario? you had your own HP servers, for example?
So the compute nodes, like Matt was talking about, it's really just matching. So you have 3 competing things. You have CPU, you have memory, and you have storage. If the storage of the OmniCubes that you've deployed is sufficient for the cubes that you have plus whatever number of compute nodes, then that's great. You may have to, if you need additional I/O, that's something that you have to think about deploying another cube or OmniStack at that point. So it's the same thing with scaling your traditional 3-tier infrastructure. You have to balance those things. So it's a question of which model OmniCube or OmniStack node did you buy, how much I/O is it going to do, how many users are you trying to do, what are you trying to get additional GPUs in. Usually that's going to drive the consolidation down a little bit, and compute nodes are great for that because overwhelmingly those are very compute oriented. They're not super heavy on I/O, so the I/O of your OmniStack or OmniCube infrastructure will usually satisfy that. Sure. Any other questions?
What's your SimpliVity Max deployment that you guys have out there in the wild for VDI?
That's a great question. I don't know off the top of my head. If you wanna,
I wasn't sure if you guys had like a number out there, for a customer that's running like 10,000 desktops or something.
Honestly, that's kind of the bad thing about being in engineering. I don't get a lot of that kind of
just curious
stuff. Now we do have some sizable deployments. I can follow up. Anybody else? All right, if no further questions, thank you.